Ow. No, this is my smoothie, kitty. Hello, welcome back to Law of Creation. Today we're talking about the origin of us. Was it a primordial soup or a thermodynamic engine? I'm David. This is Nebula. This is my smoothie. This is Nebula, the physics cat. You know, she wasn't always a large physics cat. She was once a tiny little physics cat, even bottle fed. And she's going to help us navigate through these questions. So how do we reconcile our existence? And how does that relate to entropy? Entropy, right? The ultimate disorder of things. We're taught that everything in the universe goes from a state of order to disorder. Our star is going to burn out eventually. If you don't clean up your space, somehow it's going to get messier and it's going to take work to put it back together. So if it's true that these laws, the second law of thermodynamics says that everything's going to disorder, how do we explain all the beauty and order and life we see around us? And today we have real answers to this. So let's see if we can make sense of some of it. So welcome to our entropic model of the universe. So this is meant to show how everything is really related. So over here we've got the Big Bang going towards ultimate entropy. A heat death, they call it, is where in trillions and trillions of years, there will be nothing left, not even anything next to each other where time will exist, because there won't be anything to compare anything else to. Okay, we can do this. And so where do we belong on this? Well, first we have galaxies that create stars and solar systems, and then those create planets, and sometimes those planets have structures on them called weather systems or tectonic plates. And once in a while, at least we know of one, we have something complex that we begin to call life. And then those life forms produce other things. Now, is there an order, a natural order to how all of these things are related? Or are somehow we separate or not related to all of this? Is our human intelligence different than the intelligence of the universe? Well, we finally have answers to this. So let's go to our chalkboard and see if we can make sense of some of it. So when considering the existence of us, we think about the primordial soup, but how does that relate to maybe the laws of physics that we know of already? So the second law of thermodynamics would say that everything goes towards disorder, and yet we see all these structures everywhere around us. So how might we demonstrate or reconcile our creative intelligence with that of the universe? And is it separate? Well, today we actually have a formula for this, a formula for the creation not only of us and what we create, but also how we went from galaxies to stars to planets, and it all comes down to this, where the ODC, Optimally Dissipative Configuration, which might sound like a mouthful at first, but it's the common denominator, the link between how we might think we're separate with, here you go, kitty. Yep, okay. How we might think that we're separate to how we're actually doing the same thing that the universe has been doing all along. So let's say we want to build a bridge to access some new resources or to help traffic flow. There's a flow of energy that we'll talk about again and again. So that final bridge built by an engineer, and that engineer will take the best configuration of all known bridges and choose that one amongst all of the possible bridge types that we've learned about, experimented with, that have adapted in the past, within the constraints of what budget and materials we might have. Similarly, in the primordial soup, or here we'll talk about it as if it's a thermodynamic engine, when agitated or driven by some kind of force, will agitate and reconfigure in such ways that are optimally dissipative. And the universe, the system, selects and chooses the one that is most dissipative. So now we've got these structures within all of these moving systems in primordial soup within the constraints of the system. And this is how we begin to reconcile our intelligence with that of the universe, because just like the engineer learned and experimented and chose, the universe in the primordial soup experiments or agitates all these different configurations of amino acids and pre-life elements. And when there's a configuration that helps the system move energy and matter more, the universe will select and choose that one. And that, my friends, is how we are linked to the rest of the universe, how we are not so separate after all, and how we're able to seemingly go against entropy, but actually we're always falling from one dissipative state to the next, always going downhill in that sense. So as far as ODC, so the argument of the maximum, which is a fancy physics term saying that we're selecting or choosing the configuration that has the best qualities we're looking for. Whether it's a human designing something, we're going to take the optimally dissipative. This is where, of all the possible selections, we're going to choose the one that helps energy and matter move into the final configuration. Now let's see if we can demonstrate this in real time using our atomizer. So what we have before us here is a representation of all elements, atoms, amino acids in the primordial soup, but we're going to look at it from a thermodynamics engine point of view. This could also represent all the possible designs for that bridge we talked about before, all the configurations that cost too much even, or the ones that don't work so well. They're all in the same soup, and when we're going to apply a driving force to it, they're going to automatically configure themselves into the most dissipative structure, and we have no idea what that's going to look like. And that's important when considering looking at the final product, such as us or anything in this room, and we might say, oh my goodness, it would be impossible to design such a thing. But it also took 4 billion years of step-by-step little steps of becoming more dissipative each time and working with each other. Then eventually we get something like this. Are you ready? Okay, let's see what we made here today for the first time ever. So we have something that looks like this, maybe like this one here. Oh, that's a nice one. So this is meant to be a microcosm, a miniature version, maybe a pin-sized example of what was happening for millions and millions of years in the primordial soup, when all of these atoms and elements are seemingly randomly and chaotically moving, but actually they're configuring themselves into the most dissipative structure. And most of the time, nothing will happen. But sometimes a perfect storm happens where these amino acids or pre-life building blocks will configure themselves in a way that they actually help the flow of energy and or matter in such a way that it will form a new configuration that's then able to encourage more of the same to occur. And that, my friends, is how we begin to have more and more complex structures, if the planet allows it, if there's not some greater gradient coming along, like an asteroid or something that's going to destroy the planet. If it's allowed and it has enough time, eventually we get us. And that's how we're connected to the rest of the universe. So I hope this is starting to come together for you. I know I'm throwing a lot out there at you, and I do appreciate your feedback and comments and questions. No, kitty, no. Ow. No, this is my smoothie, kitty. Oh, and she's here to remind us too that I've got a whole series of illustrated books on the topics that we explore here called Entropy, the Sentient series. And you've got all these illustrations and kind of poetic text trying to bring it to life in a simple way, hopefully entertaining. You know, she wasn't always a large physics cat. She was once a tiny little physics cat, even bottle fed. And I love your feedback. Should I do more of this, less of that? Am I going too fast? Am I going too slow? Do we want to see more Nebula, the physics cat, or less? And I hope you get that experience of starting to see how everything does fit together. We're not so separate from the universe after all. We are made of stardust, and now by comparing the primordial soup to a thermodynamic engine, you can kind of see how physically it was inevitable for us to even emerge from all of this. And this would apply also to aliens if they exist out there. They would have to follow these same rules and laws of physics of optimally dissipative configuration. So I appreciate you joining us on this edition of Primordial Soup or Thermodynamics Engine. And we will see you next time on Law of Creation.